Hello everyone, welcome back to Firepower Report. Today we dive into one of the most staggering and consequential developments of our time, 93 Ukrainian drones striking Moscow. The scale alone shocks, but what truly demands attention is the technological prowess, the tactics, and the strategic message behind it all. We will examine every angle how these drones look and are built, what's inside them, how they perform, their protective systems, what sets them apart, how much they cost, and ultimately what this means for the future of warfare. When you think of a drone strike on a capital city like Moscow, images of big missiles or stealth bombers might come to mind, but these drones look deceptively simple and unassuming. Their exterior is sleek, minimalist, built for stealth and efficiency. The airframe is compact and streamlined without bulky protrusions. The surfaces are often of matte or semi-matte composite materials that reduce reflectivity, and with that, radar signature. You will rarely see large wings or big fins. Instead, many of them use folding or stowed wings to make them easier to transport and harder to detect. The coloring tends toward dark grays, black, and camo tones, blending with the night sky or the urban horizon. Their small size means they can evade radar or be masked by clutter, especially in dense air defense zones. Every external component, propellers, sensors, fins, is designed to minimize drag and electromagnetic visibility. The joints and seams are tightly sealed to avoid revealing internal electronics to detection methods. Even the smallest detail matters. The lines are clean with no excessive protrusions or antennas sticking out. Any sensor or communications gear is tucked away or made retractable. When you see footage or renderings of these drones approaching Moscow, they appear like ghostly specks, difficult to distinguish until they are very close. Inside, the design prioritizes compactness and efficiency. There's no wasted space. A high-density power source, often a fuel cell, battery pack, or hybrid system, sits in the core. Around it are navigational components, GPS modules, inertial measurement units, processing boards that manage flight control and guidance, electronic warfare modules, and the warhead or payload section. Wiring is tightly routed, shielding employed to reduce interference, and the internal layout is optimized for center of gravity stability. The warhead compartment is carefully placed to balance flight stability while allowing sufficient destructive power. Cooling systems, albeit modest, are included to manage heat from electronics during long flights or when operating under load. Overall, the interior is a marvel of miniaturization. Everything crammed yet functioning reliably under extreme conditions. It's this efficient internal architecture that allows the drone to carry enough fuel or energy for long missions while also mounting effective payloads. In terms of performance, these drones are designed for endurance, precision, and coordination. Their range often stretches into the hundreds of kilometers, allowing launches deep inside friendly territory while striking targets far behind enemy lines. The flight profile is optimized. An initial climb to efficient cruise altitude, then gliding or powered cruise modes to conserve energy, and descent guided by terrain, following or waypoint algorithms to evade detection. Many are equipped with GPS guidance integrated with real-time correction and redundancy, so if GPS is jammed, inertial navigation takes over. Some even include optical or infrared sensors to adjust terminal approach, honing in on precise targets in urban environments. Their speed is modest, fast enough to cover distance, but slow enough to avoid creating a large acoustic or radar signature. What sets this strike of 93 drones apart is the swarm capability. They don't fly solo, they fly together. They're programmed to coordinate trajectories, maintain spacing to avoid collisions, share data about obstacles or defense zones, and time arrivals to overwhelm air defenses. By saturating defenses with many small threats instead of one big one, they force resource expenditure, missile interceptions, radar hours, and the mental strain on defenders. The success of striking Moscow again with such a swarm proves the concept: quantity, coordination, and resilience trump singular large assets. The drones can also loiter in holding patterns or wait in safe zones until the optimal attack window. If conditions change, weather, defenses, trajectories, the mission plan can adapt in mid-course. In short, performance is not just raw speed or thrust, it's agility, coordination, endurance, and fault tolerance. Safety in a combat system is a different concept than in civilian machines. These drones incorporate fail-safe mechanisms. If they risk being captured, they may self-destruct or detonate in a manner that prevents reverse engineering. They often include encryption of communication links, anti-jamming modules, and redundancy in critical systems so that a single failure won't doom the mission. Signal links are secured. Control commands may use frequency hopping or spread spectrum to avoid interception or spoofing. If GPS is jammed, backup systems will maintain flight via inertial reference, optical flow sensors, or terrain mapping. Some drones feature return to home codes or fallback landing protocols if connectivity is lost, though in high-risk missions that may be suppressed to avoid capture. Thermal management, shielding of sensitive electronics, and hardened components ensure performance even under stress. In aggregate, these safety features protect the mission integrity and reduce chances of losing valuable assets to the enemy or having technology fall into adversarial hands. What really makes these drones stand out, their unique selling points, is how they reinvent the cost-benefit equation in warfare. They're inexpensive compared to missiles, modular, upgradable, produced at scale, locally manufactured, and adaptable. Instead of spending millions on one cruise missile, a nation can deploy dozens or hundreds of drones that collectively create an overwhelming effect. Each drone can be upgraded. Better sensors, more efficient power systems, improved payloads. Because they are built in numbers, loss of some is expected. Resilience is built in. Their modular nature allows quick repairs, swapping parts, and iterations. They are not dependent on one monolithic platform vulnerable to a single failure or loss. Another selling point lies in surprise and psychological impact. Striking the capital city of a major power shakes confidence, forces overreaction, and compels resource reallocation toward defense. The drones operate with ambiguity, small, hard to categorize, hard to counter fully. They also democratize strike capability. Nations or groups without large air forces can wield meaningful pressure deep into enemy territory. The swarm logic is itself a force multiplier. Many small actors acting in synchronization become a complex, high-threat entity. Finally, the message sent by 93 drones hitting Moscow is symbolic. The inviolability of distant borders is shattered. When we think about price, the contrast is staggering. A single cruise missile or high-end air-launched weapon can cost from hundreds of thousands to millions of dollars. Building or deploying a drone of this class might cost anywhere from tens of thousands to low hundreds of thousands depending on sophistication, payload, sensors, and range. Even if costs run higher for advanced versions, they remain a fraction of missile systems. Consider the aggregate effect. Deploying 93 drones may cost a few million, whereas defending against them or repairing the damage they cause may run significantly higher. From a strategic budget standpoint, drones offer scalability. Nations can field large swarms without breaking defense budgets. Losses are expected and tolerable. Replacement is cheaper and faster. Over time, incremental tech improvements can be folded in across thousands of units, sensors, propulsion, algorithms without redesigning entire platforms. The economic sustainability of drone warfare is a fundamental shift. Cost curves that once favored heavy platforms now tilt toward distributed small systems. In conclusion, the recent strike of 93 Ukrainian drones on Moscow isn't simply a headline, it's a glimpse into the future of conflict. A future where stealth, coordination, affordability, and adaptability define power far more than sheer size or singular technological excellence. These drones, lean in design and lethal in execution, epitomize that shift. They demonstrate how a determined actor can challenge air defenses, strategic depth, and symbolic strongholds at a fraction of traditional costs. The defenses that once looked inviolable now face small, smart, numerous threats. The message is as much psychological as it is physical. No place is beyond reach when technology and strategy combine. If we want to understand tomorrow's wars, we must watch how systems like this evolve, adapt, and proliferate. The era of the drone swarm isn't coming, it's here already. Thank you for watching this deep dive. If you found this breakdown illuminating, please like, share, and subscribe to Firepower Report. Stay tuned for more analyses on the innovations and escalations shaping our world.